Mastering data transfer protocols. Its data transfer protocols are only as good as the KPIs that measure them. Which key performance indicators, KPIs, does its organization use to measure the efficiency of its data transfer protocols and gauge their effectiveness in achieving operational excellence? In the realm of data transfer protocols, operational excellence is paramount to ensuring seamless, efficient, and reliable data exchange between systems, applications, and stakeholders. To measure the efficiency of data transfer protocols and gauge their effectiveness in achieving operational excellence, organizations typically employ a range of key performance indicators, KPIs. These KPIs provide valuable insights into the performance, reliability, and scalability of data transfer protocols, enabling organizations to identify areas for improvement, optimize their protocols, and make data-driven decisions. Throughput and utilization. One critical KPI is throughput, which measures the volume of data transferred within a given time frame. This KPI is usually expressed in terms of bits or bytes per second, BPS. By monitoring throughput, organizations can determine whether their data transfer protocols are operating at optimal levels, identify bottlenecks, and adjust protocol parameters or infrastructure accordingly. A related KPI is utilization, which measures the percentage of available network bandwidth or system resources allocated to data transfer. This KPI helps organizations ensure that their data transfer protocols are not overloading or underutilizing system resources. Latency and response time. Latency, measured in milliseconds, ms, is another essential KPI that represents the delay between sending a request and receiving a response. Lower latency values indicate faster data transfer and improved user experience. Response time, which is often used interchangeably with latency, measures the duration between sending a request and receiving a complete response. This KPI is particularly crucial for real-time applications, such as video conferencing or online gaming, where high latency can lead to poor user experience. Error rate and packet loss. The error rate, expressed as a percentage, measures the number of errors encountered during data transfer. A high error rate can indicate issues with protocol configuration, network congestion, or hardware malfunctions. Packet loss, which represents the percentage of packets lost during transmission, is another critical KPI that affects data transfer reliability. By monitoring error rate and packet loss, organizations can identify and troubleshoot issues, implement error correction mechanisms, and optimize protocol settings. Availability and uptime. Availability, typically measured as a percentage, indicates the proportion of time that data transfer protocols are operational and accessible. Uptime, which is often used interchangeably with availability, measures the duration for which data transfer protocols are continuously available. These KPIs are vital for ensuring that data transfer protocols are always accessible, reliable, and meet business continuity requirements. Protocol efficiency and overhead. Protocol efficiency, which measures the ratio of payload data to total transmitted data, is an important KPI that indicates the overhead introduced by the data transfer protocol. Lower protocol efficiency values indicate higher overhead and potential performance degradation. By optimizing protocol settings and selecting efficient protocols, organizations can minimize overhead, reduce bandwidth consumption, and improve data transfer performance. Scalability and capacity. Scalability, which measures the ability of data transfer protocols to handle increased load or traffic, is a critical KPI for organizations experiencing rapid growth or high volumes of data transfer. Capacity, which represents the maximum amount of data that can be transferred within a given time frame, is another related KPI. By monitoring scalability and capacity, organizations can ensure that their data transfer protocols can adapt to changing demands, handle peak loads, and maintain performance. Security and compliance. Finally, organizations should also monitor security-related KPIs, such as encryption strength, authentication rates, and compliance with regulatory requirements, e.g., GDPR, HIPAA. These KPIs ensure that data transfer protocols adhere to organizational security policies, protect sensitive data, and maintain regulatory compliance. In conclusion, by tracking and analyzing these KPIs, organizations can comprehensively evaluate the efficiency and effectiveness of their data transfer protocols, identify areas for improvement, and make data-driven decisions to achieve operational excellence.